everyone, thank you so much for joining this video. Today we're going to be looking at the characteristic physical properties of group 7. So we're going to look at the existence of halogens as diatomic molecules and the explanation of the trend in the boiling points of chlorine, bromine and iodine in terms of induced dipole-dipole interactions. So now we're going to talk about group 7 elements, and these are called the halogens, and they're all nonmetals and exist as diatomic molecules. So for example, fluorine exists as F2, so it exists as 2 atoms of fluorine in one molecule. So there are particular things to know about each of these halogens. At room temperature, fluorine is a pale yellow gas, chlorine is a green gas, bromine is a red-brown liquid, and iodine is a black solid. So these are really important to remember because you can be asked about it, or when you're forming equations, sometimes you need stuff in their standard states. So for example, when you're doing questions about Hess's law maybe, and so you need to remember that fluorine and chlorine are gases, bromine is a liquid normally, and iodine is a solid. And so the trends we have for group 7 are that the atomic radii increases down the group, and this is because the number of electron shells increases. So for example, fluorine is in period 2, so its outer electron is in 2p5 compared to chlorine, which is in period 3, so its outermost electron is in 3p5. So it has that extra electron shell, and so the atomic radii increases. The second trend we have is that electronegativity decreases down the group. Electronegativity is the power of an atom to attract the electrons in the covalent bond, the pair of electrons in the covalent bond. And so because the atomic radii increases when we go down the group, that means there's more shielding, so the electrons in that covalent bond do not feel as big an attractive force from the positive nucleus compared to atoms which are further up the group. And then the third trend we have is for boiling points, and these increase going down the group because they're all non-metals, and because they get bigger, they have more electrons, and therefore they have more van der Waals forces, which makes them stronger. So they have stronger van der Waals forces between the molecules, and so more energy is needed to overcome them. And so the group 7 elements at the bottom have much higher boiling points compared to the ones at the top. And the reactivity of group 7 elements decreases down the group, and that's also because of the extra electron shells. So there's more shielding between the electron that it wants to gain to form a 1- ion and the positive nucleus. And so going down the group, it becomes harder and harder to gain an electron to form a 1- ion. And so that's why the reactivity decreases going down the group.